Hi, welcome back to Epic. As usual, I hope you're doing amazing. Today, I'm going to talk about some key concepts that you will commonly find in climate change scientific papers. Before I start, I'd like to mention that most of the slides in today's lesson come from an obsolete climate change course that used to be offered by the University of Melbourne. So, I don't know the precise reason why that course was taken down, but I did find that some of the information is out of date, so I did my best to update it, but it is not perfect. So let's start from the top. And the first concept is exposure. Now, exposure is very easy to explain because it's basically what are the dangers posed by climate change. For example, it can mean that the temperature is going to be 1 to 3 degrees higher by the end of the century. Maybe it will be 2 to 4 degrees actually higher, and 4 to 6 degrees higher in the worst case scenario. Precipitation, depending on the area you're in, it might experience a decrease of about 14%, but in other parts of the world, it may increase by 14%. So you're going to get more droughts and more floods. Extreme weather events are probably going to be more intense, although it is not certain yet about their change in frequency, whether they will happen more often or not. Sea levels will rise by 9 to 88 centimeters by the end of the century, and there's going to be an increased frequency of coral bleaching, and it's already happening right now on a massive scale. But the precise effects will vary from one region to another. The next concept I'd like to introduce is sensitivity, and in this case, it means whether a building or an environment is susceptible to damage. And as you can imagine, this varies whether you are in a first world country and a third world country. And just to go over this in a bit more depth, for example, it may mean that the response of the coasts depends on their morphology. Like, is it cliffs, rocky substrate of various types? Is it rock? Is it sand? Is it mud? What's the sources of sediment? For example, is it from erosion or is it from longshore transport from adjacent coastal areas, etc.? It also depends on coastal developments because wharfs, seawalls, and sand mines increase the likelihood that coastal areas will be damaged by climate change. Now we move on to adaptive capacity, and this is the ability to get out of harm's way or reduce susceptibility to damage. Adaptive capacity largely depends on the fact whether your nation is rich or not. For example, if you look at some Pacific Island nations, urbanization in Papua New Guinea is only 13%, but in Nauru, it's 100%. The GDP per capita is around $2,700 in Papua New Guinea and $20,240 on the Cook Islands. The percentage of population below the poverty line is 13% in Niue, but it's 53% in the Marshall Islands. Maternal mortality rate per 1,000 births is between 16 in Palau to 36 in Papua New Guinea. And just to conclude, the percentage of students completing primary schooling is 77% in Papua New Guinea compared to 100% in Niue. And the percentage of households with electricity is between 66% in Solomon Islands to 100% in Tuvalu. So, various nations are at various stages in their development. We cannot have a one size fits all solution when it comes to climate change. We have to have a solution for location A, and it's a different solution for location B, etc. And when you do talk about Pacific Island nations, most of these countries are ranked in the lower half of countries in the world for human development. These are places like Kiribati, Papua New Guinea, Solomon Islands, and Tuvalu. Most economies there, as I will show a bit later, are dependent on a primary production. So they basically have one primary source of income. It can be fishing or bananas, but it's one source of income. And if it gets destroyed, let's say in a fire or a flood, then the country becomes paralyzed. So, of course, you might say, well, it would be nice for them to diversify their portfolio. And that's a very nice thing to say if you're coming from somewhere like the US, where you have a huge amount of land and access to vast resources. So you're not dependent on just one source of income. You can trade thousands of things. That's very nice. But in these type of places, as I'll point out later, the amount of land is very limited. It's extremely vulnerable. And if they rely on the primary production, they don't really have anything else to switch to. Lastly, I want to talk about mitigation and adaptation because these two words you'll encounter a lot in climate change literature. So, the big difference here is that mitigation is some sort of preparation before an event, and adaptation is something you do during or after the event already occurred. One example of mitigation is an effort to reduce or prevent emissions of greenhouse gases, and that means a transition to renewable energy and reducing deforestation. Adaptation, on the other hand, is action that helps to cope with the effects of climate change. That can be a new barrier to protect against sea level rise. So, here are some key differences between mitigation and adaptation so you can understand it better. Mitigation is reducing the cause of climate change, for example, reducing the amount of greenhouse gases we pump into the atmosphere. Adaptation, on the other hand, is adjusting to the unavoidable impacts of climate change. Mitigation is usually a bunch of global solutions, while adaptation solutions are localized and specific to a region. When we talk about mitigation, one example of a policy would be to limit well below 2 degrees Celsius global average temperature increase since pre industrial levels, preferably limiting to 1.5 degrees Celsius. But adaptation could mean increasing adaptive capacity by strengthening resilience of buildings, for example, and reducing vulnerability to climate change in the future. Key indicators of mitigation can be easily quantifiable, for example, the reduction of greenhouse gas emissions. Adaptation, on the other hand, is hard to quantify. The impacts are maybe averted and the vulnerability is maybe reduced, but we don't know for sure. Mitigation, since it's a long term thing, it's very highly politicized in most instances, while adaptation is very depoliticized and technocratic in most instances. When a disaster happens, there is no room to argue about politics. You just have to deal with the problem. Finally, I want to give you some examples of mitigation and adaptation. Mitigation, for example, would be things like energy conservation and efficiency, renewable energy, sustainable transportation, and improved fuel efficiency, but also carbon sequestration and increased carbon sinks. So that would mean planting more trees, for example. Adaptation is during or after a disaster has already happened, so now you have to adjust. This can mean change in land use, people relocating, upgrades and hardening to infrastructure. Finally, it can also mean something like a smart growth, so that in the future you don't repeat the same mistakes and you're building an economy that is future proof. And I want to finish here by mentioning a climate security workshop report from June of 2019. And there's one formula which they came up with. And basically, the formula goes something like this: climate related security risks are equal to hazard times exposure times vulnerability and coping capacity. Hazards can include heat waves, desertification, and floods, etc. Exposure means affected populations and affected assets, as well as the economic fabric. Finally, vulnerability and coping capacity refers to community mechanisms, state mechanisms, governments, organized migration, vulnerable groups, etc. And as I mentioned before, uh, this depends on the geography and the resources available in a particular nation. For example, if you're somewhere in Russia, Russia doesn't have many people for the amount of land that there is. If something happens, then people can easily move inland, away from a coastal disaster. But in a poor nation with very limited amount of land, this is very difficult and maybe even impossible. And maybe these people have now to move to, say, Australia or New Zealand. So I will give you examples from three different nations and how they are reacting to the effects of climate change. I like to provide as much information as possible in this course, so if you ever ask questions, you can explain what the problems are. So, what exactly are the direct risks to the societies I just mentioned? Well, for example, there are health risks, health issues like malaria or dengue fever, and of course, from natural disasters as well. Food security. If a flood comes in and wipes out your agricultural production, you're pretty much done. You'll rely on foreign aid for a while. It can also mean your fisheries are damaged. Maybe, all your fishing boats are damaged. And so maybe for days, weeks, you're completely paralyzed in a sector. It can also mean danger to clean water because you have saline contamination and drought. Finally, as I mentioned before, you can have damage to the infrastructure, for example, a hospital, and now people can't use it at all. You can have damage to roads, energy systems, and water supply systems. And this damage generally impacts the amount of jobs in that country as well as economic growth. And finally, at least temporarily, it drives the costs of living up because as something becomes more scarce, the prices go up. So now there is less land available, but it will be more expensive. The next concept I'd like to talk about is vulnerability. Vulnerability is the degree to which a system is susceptible and unable to cope with adverse effects of climate change. It is a function of the character, magnitude, and rate of climate change and variation to which a system is exposed, its sensitivity, and its adaptive capacity. And this comes from the IPCC report in 2007. And just to put this in a bit more context, if you look at a place like Majuro, which is the capital of the Marshall Islands, and you can find many images on the internet, go ahead. So, when Japan experienced the horrible earthquake in 2011, the tsunami height is estimated to be about 38 meters. And despite all of that, the vulnerability factor in Japan was probably not very high. But if you're talking about a place like Majuro, if you got a 38-meter tall tsunami there, you're talking about 100% destruction. So vulnerability highly depends on where you are geographically. It depends on the geography itself and also on the type of buildings and infrastructure. As I mentioned before, the conditions, of course, are not the same in every country. If you look in a country like Niue, for example, it only has an area of about 260 square kilometers, which is not a lot. And in fact, it has a population of only 1,600 people or so. Generally, these type of countries are very reliant on a primary source of income. And even though they are trying to diversify, it's quite difficult. And if you look at the economy of the Marshall Islands, actually 60% of their budget comes directly from direct US aid. This is under the terms of the amended Compact of Free Association. So while the Marshall Islands depend on US foreign aid, a country like Niue depends on New Zealand. The Marshall Islands economy heavily relies on fishing, breadfruit, as well as banana, taro, and pandanus. To give you a bit more perspective, there is a tuna processing plant there that employs about 300 people, mostly women, and they get paid $1.50 per hour. They are trying to expand fishing, aquaculture, and tourism. And then finally, if you look at a place like Florida, first of all, in Florida, there is Governor Rick Scott, who is a very staunch climate change denier, because obviously in the States, there are vested interests. The fossil fuel industry spends millions of dollars every year to basically cast doubt on the science, etc. It is estimated that the sea at the southern end of the Florida Peninsula has risen a foot since the 1900s and almost 5 inches since 1993. Of course, it depends how you measure it. It's not always the same starting point, and that's why you have slightly different figures. Some scientists say that another 6 inches of sea level rise could well arrive by 2030, and infrastructure planners are bracing for 2 feet by 2060. So, in Florida, one thing they're doing, for example, is raising the streets. And as you can imagine, I talked about that before, cement production is not great for emissions. And also by raising the roads, well, it's really expensive. And secondly, all it really does is not really tackle the elephant in the room, but basically just applying a small patch to the wound. The problem still exists. Basically, you're just buying yourself maybe 5 or 10 years or so. So to conclude here, the levels of development vary from nation to nation, and certain solutions, which may be applicable, say in Canada, are absolutely not applicable in the Marshall Islands. Generally, rich nations have a wide portfolio of goods, but a lot of the poorer nations rely on a primary production, and that is absolutely, if that is gone, then those communities are completely paralyzed and have to depend on international aid for a while. Okay, so next time I will talk about the evolution of climate science and climate models.